Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 3, Section 5, Arithmetic Sequence as Linear Functions. Okay, so why? During a 2,000-meter race, the coach of a women's crew team recorded the team's times in several intervals. At 400 meters, the time was 1 minute 32 seconds. At 800 meters, it was 3 minutes 4 seconds. At 1,200 meters, it was 4 minutes 36 seconds. At 1,600 meters, it was 6 minutes and 8 seconds. They completed the race with a time of 7 minutes and 40 seconds. Okay, so when you have these, the meters increasing by 400 and the minutes increasing by a certain amount, and if it's consistent, they meet the completed race time with 7 minutes and 40 seconds. So when we have like intervals that are consistent, you can recognize that there's a pattern there. You can relate the pattern of team times to linear functions. So a sequence is a set of numbers called the terms of the sequence in a specific order. Look at the pattern, look for a pattern in the information given for a women's crew team. Make a table to analyze the data. So for distance, you see it increased by 400 here. And then for time, it increased by 1 minute and 32 seconds each time. As the distance increases in regular intervals, the time increases by 1 minute and 32 seconds. Since the difference between successive terms is constant, this is an arithmetic sequence. The difference between the terms is called the common difference, D. So we're going to use the letter D for the common difference. Okay, so this is actually the common difference. Each one is 1 minute and 32 seconds. Okay, arithmetic sequence. So again, an arithmetic sequence is a numerical pattern that increases or decreases, it can decrease as well, at a constant rate called a common difference. So 3, 5, 7, 9, 11 is adding by 2, so 2 is the common difference. 33, 29, 25, 21, and 17 is subtracting by 4, so the common difference is negative 4. Okay, so it's decreasing, it's a negative number. Alright, so for example, identify an arithmetic sequence. Determine whether each sequence is an arithmetic sequence. So it's a yes or no, is it or is it not? And explain. So negative 4, negative 2, 0, 2, you can see that it's increasing by 2. Therefore, the difference between terms in a sequence is constant. Therefore, the sequence is arithmetic. Here you have 1/2, 5/8, 3/4, 13 over 16. Each time it increased by 1/8, and then this time here is 1 over 16. So it is not an arithmetic sequence. The difference between terms is not constant. So it is not an arithmetic sequence. Alright, so here's your turn, 1A, 1B. Determine whether each sequence is an arithmetic sequence, and then explain. So see if there's a common difference in between, and if it does not, then it is not an arithmetic sequence. Okay. Find your next term. Find the next term, 3 terms of the arithmetic sequence 15, 9, 3, negative 3. Okay, so it's decreasing by negative 6. So you can do that by subtracting the numbers each time. And the difference is negative 6. And then, so if the common difference is negative 6, you know the next number is going to be negative 3 minus 6, which is negative 9. And then minus 6 again, negative 15. And then one more time, and negative 21. So the next 3 terms in the sequence are negative 9, negative 15, negative 21. Right, so here's your turn number 2. Find the common difference and then the next 4 terms. Okay, so tell me what 1, 2, 3, 4 numbers are. Whoops, 4. Alright, welcome back. Each term, excuse me, in an arithmetic sequence can be expressed in terms of the first term, a1, and a common difference, d. So if the first term is a1, the next term will be a1 plus the common difference, d. For example, if it's 8, and the common difference is 3, so it would be 8 plus 3, which is 11. The third term will be a1, the first one, plus 2 times the common difference, which will be 6, and now it's 14. And you add 3 times the common difference to the fourth term, and you have 17. So each time you have the original number, and then you're multiplying the common difference, but it's by subtracting one number. Okay, so this is the actual equation that's really important here. The first number, a1, plus n minus 1, okay, n minus 1 times the difference. Okay, so n is an nth term. So if I'm looking for, what about if this continued, I'm looking for the 12th term. Okay, that means I'm going to do a1. Oh, I'm going to do a1, oops, plus, and well, n is now 12 minus 1. Sorry about that. This is not my bamboo. I actually borrowed Miss Kang's bamboo. It's a little bit different. So my pad is not my normal pad that I use, so it's a little different. So now you have a1 plus 11 times d. Okay, if I wanted to find out what the 12th term is. Okay. Alright. So again, here is the equation. Okay. a1 is the first number plus the nth term, whichever term you want to find, minus 1 times d, the common difference. So here's an example. Find the nth term. Okay, so write an equation for the nth term of the arithmetic sequence. Here it is. The first job you need to do is find the common difference. So find d. So what is it going by? It's adding 4. Even though it's negative numbers, you know it's increasing. So it's adding by 4. So d is 4. So you want to find the first term is negative 12. So negative 12 plus n minus 1 times 4. Okay. Now we can simplify this by using distributive property. So 4 times n minus 4 times 1. And then you can simplify the negative 12 minus 4 becomes negative 16. So now you have 4n minus 16. Okay. So that was the answer for part A. Part B is find a ninth term. So if I kept on going, so this is 1, 2, 3, 4. So 5, 6, 7, 8, 9. So what is that number going to be if it keeps going? So instead of adding 4 each time, I'm going to substitute this n with 9. So now you have 4 times 9 minus 16. You have 36 minus 16, and you have 20. So even if I don't do all these numbers, I know the ninth number will be 20. Okay. Pretty cool. Alright, graph the first 5 terms of the sequence. Okay, so all we're doing is, instead of n, you're going to put 1, 2, 3, 4, 5, find out what the number is, and then you have 1 and negative 12 as your coordinates, so 1, negative 12, and then you have 2, negative 8, 2, negative 8, and keep going, and you see it has a trend, it's a line going upward. So which term of the sequence is 32? So now it's kind of going backwards. Which term, if I have 32 as the answer, what term would that be? So instead of a1, at the a to the nth term, I'm going to put 32 and find out what n is, and you find it's 12. So the 12th term, the 12th number will be 32. Okay, here's your turn, numbers 3a to 3d. So here are your sequences. Write an equation for the nth term, find the 15th term, graph the first 5 terms, which term is the sequence if negative 114. So it's all the same examples we just did in the example together. So if you're not sure, go back and check. Okay, you can go back on the video and check. Alright, and when you're done, come back. Right, here's a real world example. Alright, when Latina turns 15, her family may host a quinceanera. I can never say it wrong, sorry, for her birthday. So, you know, when they turn 15, they have this big elaborate party, and it's a traditional Hispanic ceremony and reception that signifies the tradition from childhood to adulthood. Okay, so Marisol is mailing invitations to her quinceanera. Okay, the arithmetic sequence 42 cents, 84 cents, $1.26, $1.68 represents the cost of postage. Write a sequence to represent the sequence. All right, so here are the numbers we're concerned about. Okay, and this is the first term, and the common difference is 42 cents. Okay, so you have A1, the first term, 42 cents, plus, I don't know what nth term is, minus 1, the common difference is 42 cents. So I'm going to simplify this by doing the distributive property. So 0.24 times n is 0.24 n minus 0.24. So you have here cancels out. Now you have 0.42 n. So that's your equation right here. So that was your equation, that's your function. Now graph the function and determine the domain. So 1 means 42. If you have 2 of it, it's 84 cents. So 3, you have $1.26, and there's a trend, and there's your graph. The domain of a function is a number of invitations. So, and this number here, usually the x-axis, is the number of invitation, and that's the domain. So the domain is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it continues. Alright, so here's your turn number 4, and this is the last slide. So go ahead and do the last problem number 4. The chart below shows the length of Martin's long jumps. So anything here, 1, 2, 3, 4, that's the domain. Okay, write a function, so write an equation that represents this arithmetic sequence. Okay, and when you're done, make sure you put it back in your book bag for credit for homework. So thanks for watching.